Welcome to this screencast on Chapter 2, Sections 1 through 3. Basically, we're starting off talking about names and things. We're starting off with very simple, low-level programming in the small. We're focusing on the small coding exercises that you will do where we explicitly write the step-by-step instructions for the computer to follow. This is for small-scale tasks. We're not trying to solve world hunger or anything here. We're just making very small step-by-step instructions for the things. And this is a part of the bottom-up design process where we want to write small chunks of code that are reusable in a bunch of different kinds of problems. We're not talking like we did last time about top-down where we take a big problem and decompose it into pieces. This is starting at the bottom and making small chunks of explicit step-by-step instructions. Remember, a computer does things very specifically, does it step by step. It's a fetch execute cycle. It just grabs the next instruction, executes it, grabs the next instruction. And so we got to write these codes that process the instructions in a very explicit step-by-step arrangement. So what are high-level programming languages? Well, all programs, or most programs, unless you're writing in machine language like we talked about last time, are written in high-level programming languages or programming languages. Well, programming languages have a syntax, which is a strict set of rules about what is legal and what is not legal in the language. You can't write anything you want. You have to write specific rules or specific code that the language defines. It defines its syntax. For certain languages, you might have curly braces. For other languages, you don't have curly braces. Certain identifiers or keywords are reserved by the language because they mean things, but other things can be others. So it's a very controlled language that is well defined. When you write a program, your goal should be or must be to produce correct results. But that has nothing to do with the syntax, because you could write code that is syntactically correct, but it doesn't do the right thing. So that's called semantics. That's the meaning of the program. It's what the program does. So you can have a syntactically correct program that doesn't correctly calculate your grade point average. That's not very good. So you want to have both a syntactically and semantically correct program, but unfortunately, in most things, there's this concept of style. So there's good practices for building good programs. You do it efficiently, you do it readable, so that when another program is looking at your code, they can look at it and understand what's going on. It follows a nice, implements the algorithm correctly. So that's some of the things that are style. There's a lot of different ways you can actually solve these problems, but some of them are better than others. So that's when we talk about style. Is it a good style? Is it readable? Is it efficient? Is it run in the right amount of time? Is it small enough to fit on your small computer, etc.? Those are kinds of things that are above and beyond whether it's syntactically and semantically correct. So, what do we do when we program in Java? There's 3 simple steps. Remember from last time we talked about Java has a compiler that compiles the code into bytecode, and then you have an interpreter to run the program. So we need to somehow write the program in text into the computer. I'm going to show you a couple different ways to do that. There's many ways. You can use your favorite text editor. You can use an IDE to write the actual program, and then you use a compiler to compile the program, and then you run the interpreter over the program. So what is the classic first program? Basically, it's hello world. It just prints out hello world to the screen. And here on the screen, you can see our hello world program. We have a comment, we have a class, we have a subroutine, we have a statement that says print out, and then we have the closing parentheses. So let's talk about a couple of these components. First off, we have comments. So single line comments start with the / character. You can see it highlighted here. It is a comment that is ignored by the computer. Comments are just totally ignored by the computer. They do not The computer doesn't do anything with them. It's just for the programmers to let them see what's going on. It's very helpful and you're gonna write a lot of comments in this class. Then that's for a single line comment. It just goes from the / to the end of the line. If you want to do a longer than one line comment, you use the /*, the stuff, bunch of lines, and then you close that off with the */. And you can see at the top of this, we have a /* multi-line comment that describes what this program does. And the last kind of comment, which is a special kind of comment, is a java.comment. There's a java.tool tool that allows you to help document your source code. It will give you a nice web page that shows you the subroutines and methods and public member variables and all this stuff, and it builds a nice web page for all your classes, and you can refer to it as the documentation to some degree that will help other developers use your classes and your code to solve their problems. So these are comments. They're ignored by the computer, but they're very, very important for developers, so you need to write good comments. What's the fundamental part of a Java program? It must have a main subroutine. So you can see here we have a public static void main. This is the subroutine. It takes a parameter that is an array of strings. We'll talk about that later, so don't worry. And then we have a whole bunch of statements that this program will execute, one after another, after another, after another. If you don't have a main subroutine, you don't have a program. The program, you cannot run this program. You must have a main subroutine. Now, if you have a object that is part of a program but isn't where you start the program, you don't need this main. You only need the main in the start of your programs. Now, since Java is object-oriented, all subroutines have to be a part of a class. So that's just part of Java's object orientation. So we define a class by using public class. You then give the program name or the class name, and so it's going to be a program name because we have the method main in it. So we can call this program name. You can optionally put in variables and subroutines and all these other great things, and then before or after your main routine. But again, your main subroutine is public static void main, and then it has statements one after the other that get executed. So when you run this program, you're going to start at main, and then you're going to execute each of those statements until you get to the end of the curly brace and your program ends. So let's sort of wrap this up, and then I'll give you an example of how this works. Java class must be in a file called the classname.java. If you don't name it the same as the class inside the file, and it should be one file per class, the Java compiler will give you a syntax error. The name of the file must match the name of the class. So the class hello world is saved in a file called helloworld.java. The Java compiler will convert that Java code into Java bytecode and put that into another file, because you can't, if you overwrote the program and replace it with bytecode, well, you couldn't edit the program. So it creates a new class with helloworld.class. It ends the file with the .class. It's telling you that that's Java bytecode, and then the Java virtual machine runs on the bytecode. So let me give you an example of creating a simple. So this is my favorite editor. So let me create a new file called hello.java and start here. So we say public class hello. It's got to be named the same as the name of the file. Public static void main, making our main subroutine. String, type of string, args. And so now we use the system class, out.println. So the system class is a class defined in Java. It has a out, which is a static member variable that is the output to the screen. So we'll just print out hello. semicolon. I need to close my curly brace, close my curly brace for the class, save the file. Then over here I can do a ls. You can see I have my hello.java, one I just created. And now I need to compile that class, so I want to say Java C, that's the Java compiler, hello.java. And it finished. Now do I see what files I have in there? You can see I now have a hello class file. So now I want to run the Java interpreter or the Java virtual machine. So I say Java hello. So I have to give it the hello class, and I run it. Oh, I don't want the class. Java hello. You give it the class name, I'm sorry. And it prints out hello. You don't need the class, you have to tell it, because the Java virtual machine knows to look for class files. So once again, you type Java hello, and it's going to run the public static void main in my class hello. And it prints out to the screen hello. So now let me show you another way of doing that using the Eclipse IDE. So I need to create a new project, Java project. Next, I'm going to call it project 1. And then in here, in the source directory, I want to create a new class. And we're going to call it, again, hello. But the IDE, if I can click this button here that says public static void main, so it's going to automatically give me that main subroutine and give me a bunch of code. So I can hit finish, and you can see that it created my class hello. It created the public static void. It gave me this comment, a single line comment saying we need to do something. So we can delete this, do the same. Notice that it's giving me suggestions. The IDE gives me suggestions on what I want, what I want to use. So print line, and it's giving me a little red mark saying that I have a syntax error. Got a little note here that I have my code has got a syntax error. Tells me I have to insert a semicolon to complete the block statement. My text editor didn't do any of this. It automatically indented the code for me. My text editor didn't do that for me. So now I have my file. Save it. And now I can do a right mouse click, run as Java application. So the IDE's already automatically compiled it. Every time I save it, it does a compilation. And now I can run it, so it's going to run the Java interpreter, and it's going to give me the output here in the console, and you can see it printed out the word hello. So using the good IDE is much simpler, more powerful than using a command line tool like Emacs and typing command line Java C. It's still, you can do it both ways. It's valuable to be able to do it both ways, but for the most of this class, we'll talk about using the Eclipse IDE. So let's go back. So showed you how to make the Java file. The compiler, you can run Java C on it, or if you're using Eclipse, it automatically compiles it, and then you can run it by running the Java command and the name of the file, and that will interpret the Java bytecodes. So we talked about statements. We remember last time we talked about there's instructions and there's data. Well, the names of things are very important in programming languages. And the names are called identifiers, and identifiers are a sequence of one or more characters. In Java, not all languages have different programming languages have different rules for their identifiers, but in Java, the identifier must start with a letter or an underscore. Many languages have a convention that underscores mean private or use locally. Java has the concept of private, so you can use the underscore. I tend not to use the underscore at all in my identifiers, but you can use underscore. The rest of the identifier consists of only letters, digits, or underscore characters. You can't put in weird quotes or semicolons or stuff, periods. You can't put periods in identifiers. So it's letters, digits, or an underscore. Not a dash. It's letters, digits, or underscore. And in Java, upper and lowercase letters are actually different. These three hello worlds are different identifiers because they have different capitalizations. The convention that we use in Java is called camel case, where when you have multiple words in your identifier, you capitalize the words. In the case of subroutines, you make the subroutine identifier lowercase. In the case of classes, the first letter of the class name or identifier must be capitalized. So interest rate is the name of a subroutine, hello world is the name of a class. You can tell by the capitalization of the words. And notice that the second word in the name or the identifier is capitalized. So talking about variables in a very specific way, we talked last time about what variables are. Programs data is stored in memory, just the same as the instructions are stored in memory. In high-level languages, instead of talking about what location the data is stored, we have variables. They're named, and they are not the actual data, but they actually refer to the location of the data. So like the X is not the value, it's the box that holds the value. And variables in Java have types. So you have a box that holds integers, you have a box that holds cars, you have a box that holds different things. And the only way to get data into that box is you have to use the assignment statement, which uses the equal operator. And so here's two examples of a variable called rate that equals 0.07, and the variable interest, which is equal to, is assigned the current, whatever the value in rate is, times whatever the value in the box principal. So in the variable rate times, at the time that we execute that instruction, the variable interest will be stored the value of the product. So Java has 8 primitive types: byte, short, int, long, float, double, char, and boolean. The first 4 are for whole numbers, so you can have a byte, short, int, long, so those are only integers, whole numbers. They're different sizes, I'll talk about that shortly. There's 2 floating point numbers, so you can have 3.14 stored in a float or a double. You cannot store 3.14 in an int because that's not a whole number. A character, or char, which is a single character. Java uses a Unicode, so there's a lot more than just A through Z and 0 to 1. They've got a lot of different characters you can use. And then Boolean, the last primitive type, is either true or false. So there's only 2 values for Boolean, true or false. So what are the sizes of these primitive types? A byte is stored in 8 bits. As you remember, we're storing this in memory, so it's 8 bits. And it can store numbers, whole numbers, between -128 and 127. A short is twice as big as a byte. So now you can have more, you have 16 bits. You can see the range. An int is twice as large in number of bytes as a short. You can see how big that is. A long is 64 bits. And if you need a number that's larger or smaller than those values, you need to do something else because you can't store it in any of the predefined primitive data types. So you can't assign 200 to a byte. It's too large, it will not fit. You can do the assignment, but what Java does is it truncates, so you're going to lose information. Floats are 32 bits, doubles are 64 bits. Because they use a floating point representation, I can't directly say what the maximum size is. There's a precision, basically there's a mantissa and a whatever the other piece is. So it's an encoding of a floating point. Chars are 16 bits, so they're the same size as shorts, but that allows us enough values to give you different, and booleans, depends on how booleans are used in the computer, whether they're 1 bit or a byte. If you're using a byte, you're wasting 7 bits because you can define true or false by 0 or 1. But again, the actual storage size, which is not very meaningful for us because we're talking about a high-level language, we don't have to worry about exactly how many bits and bytes we're using. In general, when you start getting more advanced, you may worry about how big your memory footprint is, but don't worry about that. A literal is different than a variable. It is a constant value in your program. So like the examples here are, if you wanted to have the character A and assign it to a variable, the single quote A is the literal. The next example for characters, again, you use a single quote, but that /t it's an escape T, it's a special code saying that's a tab character. So you can say, I want the tab character, and I'm assigning the tab character to my variable ch. Numbers, they're numbers, so like, since it's an integer, it's assigned 317, it's gotta be a whole number. If you want to assign a fraction number or a floating point number, you need to use a double or a floating point. You can also use scientific notation. So we can say 1.3 raised 10 to the 12th, so that's a very big number. If you said long x, you need to indicate that the 317 is a long by using the letter L after it. That tells the compiler that you're actually creating a long and not an int. Because an int, remember, is a long is twice as large as an int, so we need to actually tell the compiler that. Same thing with a double, since a double is twice as big as a float, this is a double won't fit in a float, so we would need to put an F at the end of this to indicate that we can store this same value but in half as many bytes. Now there's other representations of numbers, so if we want to talk about octal numbers, that digits go from 0 to 7, we start the number, the literal, with a 0. So int is still an int. It's an octal because it started with the number 0. 4, 5, well, that's the same thing as decimal 37. If we want to do a hexadecimal number, we start it with 0x or 0 capital X, and that represents a hexadecimal number, as hopefully you remember or we'll talk about. Hexadecimal values go from 0 to F. So here we talk about 1 times 16 plus 11, so it's 27. We can even have binary numbers. So we say 0B or 0 capital B, and we say the bits, the actual bits. And then Boolean variables or values are either true or false, but they can also, you can assign the true keyword or the false keyword, or you can assign the result of a comparison. So in the case of test 2, it will be true if bin is less than 13, or it'll be false if bin is greater than 13. The last sort of type that's not primitive that we're talking about are strings. Strings are a sequence of characters. They're not just a single character, they're a sequence. And to indicate that they're strings and not characters, we use the double quotes. And notice that we have the capital S string, and the other primitive types had lowercase. This is indicating that a string is actually a class. It's defined in Java, and so we actually can use it. They're not the same as characters, so the string A and the character B are not equal. They're similar, but one's a string and one's a character. They are not the same. One's a primitive type and one's an instance of a class or an object. And then you can use escapes, because if you had double quotes and you need quotes in your string, you have to escape them using that backslash character. And then this backslash n, again, is another symbol indicating a new line. So you can use escape characters to escape the double quotes or escape these special characters like the tab character we showed previously. Variables and programs, basically you have to supply the type of the variable and then the identifier that the variable name is. You can only use variables after they're declared. And so the declaration is this, where you say what type it is and its name. So one of the important things is you want to use good variable names. So variable names, since we can use lots of words and lots of letters, we want to actually describe what this variable is supposed to do for us in the program. So a variable of number of students is clear as to what we're going to do. That's going to count the number of students. The string name, well, that should hold a name of something. The double QW, that's not a good name because I don't know what, that's just two characters, two things on the keyboard that are side by side. I want a good description of what there are. Variables have a sense of scope. Variables declared inside of a subroutine are only visible or only usable inside that subroutine. So if you declare a variable outside or inside a subroutine and then you have another subroutine, that second subroutine cannot use that variable that is declared in the other subroutine. So there's an interesting way of managing what is visible to each of the subroutines. Talking about subroutines, subroutines are basically a set of instructions that are chunked together and have a name. They're identified, they have an identifier. They're designed to perform a specific task. In order to use the subroutine in your program, you need to call the subroutine by putting the subroutine's name, open parentheses, any parameters that the subroutine needs, and then close parentheses. You, as the user of subroutines, should consider them as black boxes. You don't care about how it works. You know what you need to supply it, you have an idea of what it's going to do for you, but you don't care how. It's a nice way of deferring the problem. You know, when we're talking about top-down design or bottom-up design, once you have a solution to the problem, you can then call it and use it and use it and use it, but you don't care how it does its job. You just care what I need, what information I need to give it. Again, like we said, in Java, all subroutines must be contained in a class. They don't stand by themselves. Static, using this keyword static, says that this subroutine is a member of the class, and you're going to use it on the class. The class system, which is a class defined by Java, has a static subroutine called exit, and what do you think the exit subroutine does? Is it quits the program. So if the program is executing and it sees that it gets to the line, the instruction system exit, it will quit the program. There are other subroutines called functions that return a value. So subroutines don't return a value. Functions are subroutines that do return a value. So for example, math.sqrt will return the square root of the value x, or throw an exception if x is negative, since we know you can't take a square root of a negative number. So here's some useful math functions. Again, math is a class that Java defines that has a bunch of static functions in it. ABS takes the absolute value, sine, cosine, tangent, exponent, raise x to power, or not power, take the natural log or the logarithm, raise x to the power, floor finds the basically the first integer value, rounds down to the integer value, and math.random is a very powerful that you'll be using in your homework assignments. Returns a random value between 0 and 0.99999. Very useful for gaming and other things. Of course, it's not truly random because computers can't be truly random, but it does give you a nice random variable. Used a lot in games and statistics and stuff. The string class that we talked about briefly, earlier, has also a bunch of nice static functions. The equals function says whether S1 is equal to X2, and it does it. Like I said earlier, case is important. So, capital S is not equal to lowercase s. So if you want to see whether they are the same letter sequence, you use ignore case. The length returns how many characters are in that. Char at returns the character at that position in the string. We're using zero-based counting, so you go from 0 to the length of the string minus 1. Substring returns the substring from the nth character to the nth character. Index of tells you where in S1 the string S2 appears. Compare to S1 and S2 says whether or not S1 is greater than, equal to, or less than S2 alphabetically. Two uppercase. Uppercase is the entire string, so all the letters become uppercase. Trim takes off white space at either end of the string. So you can have spaces in your string. Trim will remove the white spaces at the beginning and the end. And the plus operator works on strings that concatenates two strings together. And the last type of thing that we're going to talk about today is enumerations, or enumerated types, enums. So they're basically a class or a type that has a fixed list of possible values. For example, days of the week. There are only 7 of them, and you can't have another one. Seasons of the year, months of the year, planets. Of course, you'd have to remove Pluto if you put it in it, but that's beside the point. So it's a very valuable and powerful concept to say, I'm going to define the season and it's going to have 4 values: spring, summer, fall, and winter. To refer to them, you have to use the name of the enum, or the type, and the actual value that's there. You can create variables by just saying, it's now the type of this vacation is a season. The variable vacation is, is a box. Its type is a season. It has to be one of the 4 values. And if you want to do some comparison about them, you can actually ask the vacation what its position in the list. So, and it returns the 0 base. So if you say, what is vacation, and it's summer, you ask vacation's ordinal, that would return 1. So 0, 1, 2, 3. That's a nice way of sort of being able to sort of sort your enumeration. Does Monday come before Friday? Well, during the work week it does, but maybe not in the year or whatever. So you can actually figure out its location. So that's the end of my talk. So that's the first 3 sections of chapter 2. Hopefully I didn't overwhelm you, but it's pretty simple. We're talking about instructions, we're talking about variables, primitive types, strings. How do you make a program? You got to have the main subroutine. The subroutine must be in a class because we're talking Java, it's object-oriented. And how do you get the program in? You got to enter the program, compile the program, run the program in the interpreter. Thank you for your attention.